Hi, this is the lab video for Physics 2212, Lab 1, Charge Tapes, by me, Ryan Perella. The purpose of this lab is to observe the interaction between two charged pieces of tape and determine the excess charge left over. The materials used are clear tape, ruler, a flat surface, and then code in order to run the simulation. By the end of this lab, we will know that the tapes were positively charged and repel each other, and the charge on each tape was determined to be 9.33 times 10 to the negative 9th coulombs. The number of electrons lost by each tape was 7 times 10 to the 10th electron. This was done by using two charged pieces of tape, one laid on top of two computer blocks so it had elevation, and then bringing the other piece of tape up underneath of it and measuring the distance at which they started to repel each other. From here, we were able to find the force exerted onto the other tape by another one. The system is tape B, and the surroundings are everything else, including tape A. The physics principles used were Coulomb's law, Newton's second law, force equals ma, force due to gravity, which we assumed is 9.81 meters per second squared, the charge of the electron, and similar charges repel, whereas opposite charges attract to each other, and charges can be transferred to neutral objects through touch. The initial data measured is that the length of the tape is 0.2 meters, the width is 0.002 meters, the mass is 2 times 10 to the negative 4th kilogram, surface area is 0.004 meters squared, and there are 4 times 10 to the 17th atoms. The observations we found were that the U-tapes repel each other. The U-tape is attracted to the neutral table and to your hand, so when you put one end on it and bring your hand closer, it attracts. U-tape has a positive charge due to being repulsed when interacting with a pen that had a negative charge. By rubbing a pen on wool, you got to have a negative charge, and then the U-tape was repelled from it. Therefore, the U-tape is a positive charge. However, if the tape was neutral, there would be no strong attraction or repulsion from objects. On the right, you can see a demonstration of how the lab worked, where tape A was brought up to tape B, and then tape B would be pushed upwards due to the repulsive force. Some assumptions that we made are that air resistance is negligible. We treated both tapes as a point charge instead of a flat line. We also assumed that both tapes have the same net charge and that the charge was evenly distributed across the tape. Results was that tape A and tape B started repulsing each other at 0.0025 meters, and the charge of the U-tape was 1.16 times 10 to the negative 8th coulombs. In order to calculate the excess electrons, we found that force of gravity equals mass times gravity, which was 1.962 times 10 to the negative 3rd meter per second squared. The electric force must be equal to the force of gravity since it was being held upwards. Therefore, the electric force equals the force of gravity, just that same 1.962 times 10 to the negative 3rd meters per second squared. Using the electric force equation, which is similar to Coulomb's law, because we assume that the two charges are equal, it becomes Q squared instead of Q1 times Q2, just because they're equal. And we found using that and knowing the K constant, we were able to rearrange to find that Q equals 1.167 times 10 to the negative 8th coulomb. The number of electrons lost is the same as the charge of the tape divided by the charge of the electrons, which we get 7 times 10 to the 10th electron. This is the code I wrote in GlowScript in order to check my numbers and check my math. On the right, you can see the figure and the outputs. Some possible errors are that there are slight inaccuracies in the measurements of separation distance due to the nature of measuring a floating tape. Holding up a ruler next to it is not the most accurate. The tape interacting with the surroundings could have impacted the charge, such as touching our hands as we operated it, or being near the table, or the computer stands that we used to hold up the tape. There also could have been other forces that we failed to take into account, such as air resistance, and we also assumed that the charge is evenly distributed across the tape, and we used the mass we used the charge as a point charge. All of those would affect the math slightly. Now, what if electrons had a positive charge and protons had a negative charge? Well, in this situation, nothing would change because the tape would still have the same charge as the other tape, and it would still repel. Why is it important to handle the charged tape as little as possible? Well, because when we handle it, the tape comes in contact with us and is likely having a change in the charge. Therefore, we are affecting the measurements and changing the desired outcome. Thank you for watching.